Hello all, we're going to start with our third installment of the thermochemistry lecture series. First off, we are going to bring another variable into the mix, and this variable is referred to as enthalpy. So the actual variable for enthalpy is H, and that is why heat is Q, if that makes any sense to you at all. But what is enthalpy? Enthalpy is the entire total amount of thermal energy in a substance. So any substance possesses a certain amount of kinetic energy that's reliant on temperature and potential energy that's found in the bonds. Okay, but the kicker with enthalpy is we can never really determine exactly how much enthalpy a given substance has. It's almost impossible, so you don't know it. But what we can figure out is the difference, the enthalpy change that occurs due to chemical reactions or transfer from system to surroundings. Okay, so the reason we can figure this out is that as long, and here's one of those lovely little assumptions, as long as our pressure remains constant, the enthalpy change is equal to the amount of thermal energy that is transferred into or out of the system. So when we talk about delta H, the quantity or magnitude of delta H is equivalent to the absolute value of the heat of a system. Okay, so much like yesterday's lesson, when we talk about magnitude, that refers to the numerical, but then we're talking about sign and whether something is positive or negative. If my difference in enthalpy is greater than 0, so if it's positive, it's endothermic. And the reason for that is because the system absorbed energy. If the difference in enthalpy is less than 0 or negative, it's exothermic, and that's because the system released energy. Okay, so moving on up, kind of like what we were talking about yesterday again, physical changes, because we're talking about change of state, we're not making a new substance. The only thing that's really being effective are intermolecular forces, so they're like from solid, liquid to gas. That's a small enthalpy change. When we talk about chemical changes, we're making and breaking bonds, we're forming new substances, and so that represents a medium amount of enthalpy change. And lastly, the minute we start messing with our nuclei, we're making new elements, and it takes a lot of work, and for that reason, there's a large enthalpy change. So if we take a look here, here is a chemical reaction, okay? And the chemical reaction here is one where it's a net ionic equation. So we've got solubility happening here. So it's an exothermic reaction. So here are our reactants. Here are our products. And as you can see, my products have less potential energy because they lost energy to their surroundings. And losing or breaking and making bonds from the reactants to the products released energy, allowing the surroundings to get warmer. Because don't forget, like I said before, this is an exothermic reaction. And so since it's warmer in our surroundings, the kinetic energy increases. So it's like a yin and a yang. Potential energy declines, kinetic energy of the surroundings increases. Okay? So the chemical system, as I said before, and I'm just going to go back down for a bit. My chemical system involves my reactants and my products. Okay, the surroundings are anything outside of that chemical system. So when we're talking, and this is an important thing, when we're talking about calorimetry, we're talking about the surrounding liquid water. So remember yesterday we were talking about a coffee cup calorimeter, and we assume that it's an isolated system, so I'll put a lid on it. And we have water, and then we have our little system. So in this situation, this right here is my system, and my system is, in this case, my magnesium, my hydrogen, my magnesium ion, and my hydrogen ion. Okay, so that's the chemical system. The water surrounding it is my surroundings. And I'm going to run out of room. There we go. Okay, so because it's exothermic, energy is going out to my surroundings. My water gets warmer. Okay, my system gets cooler. All right, and for that reason, my delta H is negative because it's exothermic. Okay, because H2 minus H1 is a negative number because you lost some. Okay, back to this. As usual, my people, I'd like you to make sure you've read section, and I'm going to reiterate it again, 5.1, 5.2 in the text, and as usual, there's some homework for you. I'll be doing another lecture. I just wanted to stop it right now. Okay? Take care. Be good. Keep up.